here to make a couple of probability distributions and look at them on tables and graphs. This first scenario I got here, let me see here. We are going to roll a 6-sided die. Okay, so we're going to make a probability distribution for each of the options on our 6-sided die. Okay, all this does first off is assigns variables to it. Okay, so when you're dealing with a distribution, you're going to have a random variable. A variable is just determines the probability. So if I've got a 6-sided die, I'm going to first, well, I need to pick a marker first, that'd help. I'm going to first make a little table here for what my x and my f of x. And you can put a y there if you prefer. Alright, so options for me to roll on my 6-sided die. I could roll a 1. I could roll a 2. This is not rocket science. I could roll a 3. I could roll a 4. I could roll a 5. I could roll a 6. Could I roll a 7? No. They only got 6 sides on them. That's all you got. Alright, so what's the probability of me rolling a 1? 1 out of 6. What's the probability of me rolling a 2? Hey, y'all got it. What's the probability of me rolling a 3?
1 out of 6.
All the same, right?
So your y should probably be.
Alright, so we just made a probability distribution for rolling a 6-sided die. Now this one would not be one that would benefit me to go to a bar graph or anything like that because they would all be the same height. We would, I mean, you don't draw this, but this is why we're not going to draw one. You would have 1, 2, 3, your rolls down here, and then they would all be at 1/6. So you wouldn't see anything worth analyzing on that, right? Okay, let's do another one where we can see some stuff with it. Now we are going to, says let x be a random variable that represents the sum means we're adding, the sum when 2 6-sided die are rolled. Make a table and draw a histogram. Alright, so the sum when 2 6-sided die are rolled. So first thing I'm going to do is list the sample space using some of our new probability words. Remember, sample space are all the possible outcomes. So that's the first thing I'm going to do is list all of those, and then we'll go and formulate it into one of those tables like we just did, and then we'll take it to a histogram after that. Okay, so I got 2 6-sided die. I'm rolling those and looking for all the sums that I could have out of them. Okay, so I could roll a 1 and a 1, which would have a sum of 2. Let me write my sums in a different color. Oh, that's going to be a pain in the butt switching colors all the time. Let me write on the board up there so that way I can pick them up faster than I can on this thing.
This isn't our table yet, right?
No, we're just listing the sample space right now. So I could roll a 1 and a 1 and have a 2. I could roll a 1 and a 2 and have a 3. I could roll a 1 and a 3 and have a 4. I could roll a 1 and a 4 and the sum is 5. I could roll a 1 and a 6. I'll skip 5. Were you? Were you, Malia?
No.
Okay. I could roll a 1.
Equals 6.
Does it?
Yes.
Okay. Now, that's just off of rolling a 1 the first time.
1 and 6.
Oh, thank you, Cole.
Yeah.
Malia, where you at?
I was going to tell you, but you didn't tell me.
I didn't tell Kylie's shoes are on.
7.
Alright, that's just off of rolling a 1 the first time. So then we're going to have all of that off of rolling a 2 the first time as well. Okay, so here's what I'm asking you. Can I quit being ambidextrous? I'm not. I am ambidextrous, so I can't quit. But can I stop being ambidextrous right now and just write the sums? Because this is going to be a 2 plus 1, a 2 plus 2. So wouldn't those be the sums?
Yes.
Macy, you're looking like that was confusing.
No, I was just wondering, like, if you, since you already have the 1 and the 2, would you still do the 2 and the 1?
Mm-hmm.
Okay. That was all.
Everybody know where those numbers came from? I wrote a 2 and a 1, I wrote a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6. So now I'm fixing to roll a 3 and a 1. 3 and a 2, 3 and a 3, 3 and a 4. Okay, so you see the pattern, you know what's happening now. So this one's going to be okay, that was 1, 2, 3, 4. I got 2 more rounds to go, right? Can you have a sum bigger than 12 when you roll 2 die? No, because 6 is your highest, so 6 plus 6, so very good. So there's all our possible sums. Okay, so you've got that ready to look at. Now we're going to go from that to a table. All right, on my table on this one, oh, turn back on, there you go. I'm going to have an X column, which is going to be my sums. That's a row, dummy, an X row, that's going to be my sums. I'm going to have how many of those I had, so the outcomes, and you could skip the outcome ones if you're smarter than me, which most of y'all are. Then I'm going to have the probability. So I'm going to put a P of X this time for the probability of X happening. That makes more sense. All right. So possible sums that we had are all those numbers in blue. So I had a sum that came up to 2, right? See it right there? How many 2's do I have up there in blue?
1.
Only 1. So that's a 1 out of, how many blue things do I have written? 36. Okay, you got 6 both ways, so you could do 6 times 6, or you could just count them up. So I got a 1 in 36 chance of rolling a sum of 2, which means a 1 and a 1. Okay, and after that we had a sum of 3. So look and see. Where am I getting what?
Got it.
Okay, glad I could help. How many 3's do I have up there in blue? 2. So that's 2 out of 36, also known as 1 over 18. Okay, then I rolled some sums that were 4's. How many 4's do I have up there? 1, 2, 3. 3 out of 36 is 1/12.
What do you mean? How many 4s?
Well, up here where we listed sums, there's 1, 2, 3. I see 3 4's up there. All right, how many 5's did we get, Malia?
4.
Very good. 4 out of 36 is the same as 1/9. Okay, next, how many 6's did we get? 5. 1, 2, 3, 4, 5. And 5 out of 36 doesn't reduce.
I hope we get one like that.
Well, we're not done, sweetie, but yeah, that'd be nice. Alright, how many 7's do we have? 6 out of 36 is 1/6. Are you okay? How many 8's did we have? Oh, they started going back down, because see, we had a pattern here in our outcomes so far. 1, 2, 3, 4, 5, 6, but now there's only 5 8's. Okay. That makes me wonder if there's not going to be 4 9's. How many 9's were there?
4.
4.
What number is that?
Well, what was our highest sum up there?
12.
So that's where we're going. I got to start writing skinnier, don't I? Is that possible to write skinnier? I don't think so. I got to squash it together more would be what I got to do. How many 10's do we have?
3.
And what about 11's?
2.
And my last one, how many 12's?
1.
Alright, so we made our table. Now we're going to take that
And graphic.
to a histogram, and which is putting it on a graph. That's exactly right. What is a histogram, Miss Gracie?
I think it's a bar graph where the bars are touching.
It's exactly right. Thank you. A histogram, and lots of times if I see a picture of a histogram, I just refer to it as a bar graph because that's what it looks like. But the difference is what Gracie just described, and I didn't know that for a long time, Gracie, so you know it long before I did. If I'm looking here, this would be a bar graph. When they connect, that makes it a histogram. And why is that significant? I have no idea. So, all right. So we're going to put this on a histogram. You know, our sums are our x's, and our probabilities are our y's. Okay.
Like you're
Okay. So I need to go from 2 to 12 on my x-axis. It is important to label all this stuff. So this on my x-axis, that would be the sum of 2 dice. Okay, and putting the probability of rolling that sum here on the y. Alright, probabilities, they go from 0 to 1. So I don't just want to go 0, 1. I wouldn't be able to see all those little things in there. So this whole thing was out of 36s. My best chance that I had there, I think, is the 1/6. Yeah, so I don't need to go any higher there than 1/6. You could count them. We started with a 1/36, and then after that there'd be a 1/18. You can count them any way you want. I'm going to put a slash there and then a 1/9. Can't really see that with the probability written there. Alright, so all we got to do now is draw our bar to the right height, and it's a histogram, so we need to try to space it so that it connects with the adjoining bar. So the probability of rolling a 2 was 1 out of 36. I already went too high, doofus.
I don't really know fractions.
Well, why the heck not? What do you see? Alright, what I need to be real careful about, because I'm obviously not measuring or using a straight edge like I should be doing, so I need to be real careful when I have equivalent ones to try to make them go to the same height, you know. Alright, 2 went to 1/18, but it's got a hook on here to 3.
It's 136 under the 118.
1/18 is bigger than 136, so it's up higher. 4 went to 112, which would be between my 1/18 and 1/9. Five went to 1/36. It's even a little bit bigger there, isn't it?
You didn't mean to say 136, right?
No.
Yeah, it's
5 went to
1/9.
5/36. I'm on 5. So 5 went to 5/36. Right? 4, 2, 3, 4.
5 was only 1/9.
Yeah,
Oh, yeah.
because the row above.
Oh, I'm looking at the wrong.
Yeah, I was.
I got you. I got you.
Yeah,
I
that's
got you.
So 5.
So I got 2 at 136. 3 is at 1/18. 4 is at 112. So now 5 is at 1/9. Y'all are correct. I know it.
Yeah, I was about to do so.
Nobody was right with that.
Twice in one day though, Malia. I mean, that's like 6 is what I was, where I was off at. 6 goes to 5/36, which would be that next mark in between my 1/9 and 1/6.
Yeah, I never did
And then this one's 1/6.
No, I just
Yep.
would have. I probably would have written it as like 136, 236.
You could have done that. That would have been fine. Not reduced them so that way you
Oh,
know
yeah.
a better idea of how big they are. That would have been fine. All right, now 7, Malia's right, comes back down. to the 1, or goes back up to the 1/6. I'm trying to come back down to it. So.
You mean 1/9.
No?
Oh no, I'm going ahead of you.
Man, you're so fast.
Thanks.
Alright, now I'm coming back down. So this is what I was saying earlier. I need to try to get these as close to the same as I can. Okay, not the best. Thank you, Melinda. This illustrator's about to wear me out. One thing that would technically not be good on my graph is that these bars on the histogram need to be equal in width, and like I've got skinnier ones and I've got fatter ones. So if I was drawing this for something that mattered, I'd need to make sure that they were uniform and the same width, because these things down here are one of them's not better than the other, so their bars should have an equal meaning. But now we can look at this quickly. You can look at your table quickly also, but you can look at my graph quickly and say, what do I have the best chances of rolling a sum of?
7.
My nice bar, 7. What do I got the least chances of rolling a sum of?
2.
2 or a 12. Those are your lowest bars. So it's just taking this probability so that we're doing it all along and putting it in different forms so that people can analyze it and look at it. Okay, people start analyzing stuff, they always put them on graphs and stuff like that. So that's all there is to it. It's nothing hard that you haven't done since middle school. Not that big of a thing. Do you need to make any more of them?
No. I just didn't remember that 136 was less than.
When they're both ones on top, the bigger the bottom number, the smaller it is. And we usually think big numbers are bigger. The bigger the small number, because that means if I had a pizza and I had to cut it 36 into 36 pieces, those pieces aren't going to be very big. But if I only had to cut it into 4 pieces, I got some nice sized pieces. Yes. The closer the fraction gets to 1, the bigger it is. 1 over 4 is closer than 1 over 36. Because 1 and 4 are closer together than 1 and 36.
So we're done?
Yeah.
It's